Does run.
Thank you.
Okay, let me just share the correct screen. So you should see my screen, right? Oh yes, you do. So let's start. Yeah. What are we going to talk about today? I called it software architecture for data scientists because I don't want to give you the whole rundown about everything software architecture, because back when I was in university, software architecture was like one full semester with different lectures every week. So I will just give you a quick overview, and I really want to concentrate on this data science. Yeah, so what parts of software architecture are relevant to data scientists, to data analysts. So whenever you want to found your own company or you have a big data job later on, you know how to integrate, to work with engineering teams, and that's what I want to focus on. And I will give you a short intro about myself, my background, but then we will go into, okay, what is software architecture? The most important part, why does it even matter? And what fall downs and drawbacks are by choosing different architectures. Then I'm going to talk a little bit about why it is important for you as well to at least know the basics. Then we just take a look at two different types of architectures, the basic architecture that you would most likely encounter. Then we have some practical application. I hope you are fit in Python, and we were gonna have two small challenges. Yeah, and at the end, I will just explain some tools that you can use or you should know at least. And then we will have a pretty long Q&A or slot at the end where you can just ask your question if you encountered any problems, you just have an idea in mind about some application idea, or if anything came up and you want to know more. So let's start with my short introduction. I hold a bachelor's and a master's in computer science. And during my master's, I also focused on biostatistics. So there I know the in and outs of statistics, data science, and machine learning. After that, I worked as a software developer and consultant all over Germany at small to medium sized and even some very, very big companies. Then I joined a venture capital company and was the CTO there. And at the moment, I'm at DealCode, which is a company that I joined last year, and we are pretty much doing AI-guided selling. So that's the title. We are working on making predictive analysis of sales data to improve sales processes for our customers. And I'm the architect from that startup, so everything from the ground up is from me, and all the challenges, I'm the first one to tackle those. So that's just short intro from myself. And yeah, I really like the quote from Ralph E. Johnson, who wrote a very big, good and old book about software architecture. It's pretty old by now. Yeah, he said, okay, architecture is about the important stuff, whatever that is. And that's so true, because if you think about an application, the architecture has touch points with every part. Yeah, so it's about how an application is structured. Yeah, are there different components, or is everything put together once? And also, if you have multiple components, how do they communicate? Yeah, so how can we get data from one component to another? What technologies are used for which job? Yeah, usually you have multiple jobs in each application. You have multiple features. So what technologies are good for these jobs? Yeah, and the fast reply always is, because I always get the question, okay, what's the best technology for this and that? Yeah, there is no best. Yeah, it's always a matter of trade-offs. Some things are better for some use cases, some things are better for other use cases. Yeah, and then one big thing that every application, or at least every successful application, will encounter somewhere down the road: how do we scale? So what happens? Yeah, we have 100 users. What happens if we have 100,000 users? Yeah. So how can the application scale? How can we handle bigger loads? And basically everything comes down to how do we handle X, and this X could be anything. So anything you can throw at the application, all the requirements you have, everything, every cases that you have. Okay, what happens if this happens? You need to have an answer for this. And as software architecture is the foundation of every application, so at the beginning, you you think about the architecture and you start working on it. Yeah? And once you have the architecture, it's very hard to change it later on. Yeah? So basically, you are set. Maybe you heard or read in the news about some big companies who did a big relaunch of some product, and then it's basically the same product but with a different architecture, and they had teams working on it for 1 year, but no new features were developed. They had to just remove legacy code and change the architecture so it can scale in the future. Yeah? I have an example for this later on as well. So, and if we take a look at the software development lifecycle, so it starts with requirements engineering. So what do we want to build? Yeah, then and goes over the design, the evaluation, the implementation, then testing and the maintenance. So this is the software lifecycle. The architecture is involved in every part. So for the requirements engineering, if we take a look, okay, what are the requirements? Everybody always thinks first about the hard requirements. What features are we going to build? Yeah. Do we have a user registration page? Do we have some streaming service? Yeah. What are the hard requirements? But the thing software architecture is most interested in are the other requirements. Yeah, the not feature requirements. That is, okay, how many customers do we have to serve? Yeah, not all the features. So the non-feature requirements, how many customers do we have to serve? What how fast needs the application to be? Yeah, it could also be different. For example, if you have an application that's sending out emails or processing some data, yeah, slow could be okay. But if you have a streaming service like Netflix, YouTube, you don't want it to buffer every few seconds. So the speed is super important. And all this requirements engineering has to play back with the software architecture, and then also the system design. So once the requirements are cleared, you're gonna design a system, think about all the different trade-offs, think about, okay, do we need to be fast? And it's really hard to focus on the trade-offs, because if you talk, for example, to management, they always say, oh, of course it should be fast, and it should be secure, and it should be super super fast and secure, and we should have backups all the time, and it should never break. It should be available 100% of the time, and that's basically not possible. So it's always think about, okay, what are the important parts, and focus on that. Then analysis.
May I just interrupt? Yeah. What you say is basically, I got the impression that somebody is really building a software from scratch, and this is then fulfilling certain tasks. But isn't the reality more that you first make or buy decisions? Yeah, that there are many packages of it on the market that may be customized or that can be plugged in immediately, and that the company mainly have to think about where is its own USP, where it can add with proprietary software.
Mm. Yeah,
where would this fit in here?
Yeah, that could also be a part, but you have to do the same design, or you have to ask the same questions. If you buy some software or just plug something in, you have to ask the same questions basically. If you do the buy question, I'm just concentrating now on the, okay, we need to design a new software or a part of a new software from scratch. Does that answer your question, or do you have any follow-up? Okay, yeah, and then once everything is designed, you have to evaluate and analyze it. So think through everything before implementing it, and just checking. And sometimes in this phase, you also try to implement some parts of it, because you're not really sure. Think about some, if you decided to implement some new functionality that nobody in your team ever touched, you might do this here. Just see, does it really work, as promised, or as it was described on the website? If you use some package or some third party, And then during the implementation, the task of the software architect is, okay, now we have these concepts. Yeah, we have a lot of charts, we have a lot of paper basically, and now we are coding this, so everything needs to be in line. The code must match the architecture. Yeah. In big companies, you usually have the software architect who then drops off a document, 50 pages plus with everything described, and then somebody implements it. And yeah, at the same time, the software architect needs to just guide the guys and girls in the software development team, yeah, during that time and review it. Yeah. In smaller companies, you usually, the architects sometimes implement some stuff and they work closer together. And then also software architecture for system testing is super important because some architectures are better to test than others. Yeah? So that has some influence there. For example, if you have an architecture where you have very modular, many modules that who communicate with each other, yeah, you have to not only test the modules, but also the communication between the modules. You know, testing is a little bit more complicated there. If you have just one application, yeah, everything runs in this application, you basically can test it from A to Z, you know, in the application. And then also on system maintenance. So once the software is deployed, you know, and it is running, you still have to make sure that it is running and there are no problems. And in the architecture, you need to think about this as well. Yeah, just for example, do we have something like an error log implemented? Yeah, where are errors sent to? How do we handle these cases? Yeah, basically what happens if something bad happens in our application? Yeah, do we notice it, or do we need the customer to call us and say, yeah, your system is broken, which is the worst case? Yeah. So basically from this from the software life cycle, the software architecture touches everything. I already talked about the trade-offs in software architecture, and in software architecture we also say always the ilities, yeah, because scalability, manageability, modularity, there are a lot that needs to be recognized. Yeah, at least at some point, I just picked the five important ones out. Just talk about them. So when you are building an application or you are adding something to your application, yeah, as I mentioned, scalability is a big one. So what do we do if we get a lot more customers? And there you usually have two options: scale up versus scale out. So when you have your application running on a server, scaling up just means, okay, I buy a bigger server. Yeah? And scaling out means I have multiple replications of the same server. So I don't run my application on one server, but maybe on 10. Yeah, the big the trend in the industry is scaling out, you know, because that's just more fail safe, I would say. Because if you have just one big server that handles everything and that server breaks, yeah, your application is not available. But if you have the application running on 10 servers, you've got a load balancer in front of it that routes the traffic to the server that is available. And one server breaks, you have 9 other servers that can take the traffic and handle the request from the users. Then manageability, another big one. Yeah, do we know what is going on in our application, or is it a black box? Yeah, how can we manage what's going on, and do we get notified if something breaks? Yeah, do we see if for example, if we have some machine learning algorithms running on it? Yeah, do we know when the CPU usage goes over some limit? Do we get notified? What happens if that happens? Yeah, can we also scale there? Yeah, can we say, okay, we get another GPU to take over on the task? Yeah, then modularity, which is a big one in modern architectures. Yeah, I will talk about those examples later on, but basically, if we think about our application as different blocks or different components, yeah, can we just take one block off and exchange it? For example, if we have a recommendation system for a part of our application, can we just take it out, yeah, and plug on another one without breaking the whole system, yeah? Or so in this case, we could develop a new system in the background and then just exchange it without having any downtime at all. Yeah. So how modular is the system? This is a big problem for a lot of companies that started building software many years ago. They now have this big chunk of code, yeah, of applications. Everything is connected, and you can't really touch a part without breaking the whole system. And I've seen, and I've been in projects in these companies where they really invest a lot of time and money and manpower in just building something modular out of their old old code base, and because they really can't continue building new features, because when they build a new feature here, something else breaks. So that's something to keep in mind. And this is because of the architecture. When they started building it, they did not build it like we would build software today. Yeah, there were not the tools back in the days, yeah, and the frameworks that we are using now. Yeah, then extensibility. Yeah,
just one question here.
Yeah.
Sorry. So for modularity, so as you said, there are some companies that decide to be more modular and they spend a lot of resources there. Mm-hmm. So how it comes that in the beginning they didn't decide for a modular approach? So was it like someone without any software engineering background who decided to start something and then suddenly got profitable, or what?
Yeah, or they just, what happens a lot in companies at the early stages, that they want to get out software as soon as possible. You know, when they are, for example, when they are startup or they are quite small, yeah, they want to get something out to sell something, make some revenue. Yeah, so they go for the fastest way. And building software modular is costly and slower. So they just go for the, okay, let's put everything together. On top of that, if we look at some enterprise companies right now, they have software from 30 years ago running, and 30 years ago, building something modular was not the standard. The standard was to build just one application. I will talk about this kind of architecture later on, but yeah, the knowledge was not there. And also some frameworks that we are using today to enable modularity in systems, what was not in place. Yeah. And then, yeah, adding to the modularity is extensibility. So instead of exchanging something, I want to plug in something. Yeah. Now we get a new feature request, and is it easy to just add this feature, or do we need to touch the system? And a good guideline should always be, when you add an extension, you shouldn't really touch the old code. Yeah, you should maybe write an interface to connect those, but you shouldn't really change much in the code that was already there. And then for testability, as I already said, how easy can the system be tested? For example, if we have all software in one place, yeah, like we just did, like the old companies, testing is pretty straightforward. Yeah, you have the features, you know, you can test. But if you have very modular system and they are communicating, you have to test each system on their own, yeah, which has pros and cons. Yeah, but you need to test a lot more, and you need to monitor all the systems, because you now you're not monitoring the whole application, but you're monitoring every system and every service in the system. Okay, and then why does it even matter? Yeah, and big part is, yeah, architecture is about identifying the elements that are most important for the success or failure of the system, yeah, and then designing the architecture in a way that it accommodates and protects those key elements. And the first thing we're always doing in the requirements engineering is identifying these success or failure system. For example, Netflix, yeah, for them it's the microservice architecture, which means basically having a lot of small modules that are just built for one job, yeah, and this handles availability for them, because for Netflix, it's super important to be available, right? If Netflix goes out on a Sunday afternoon, the whole world rages. yeah, and they will probably lose a lot of customers. Yeah, so they say, okay, availability is number one, and microservice architecture is, we will go over this later, but it's a little bit more costly and it will take longer. But they say, okay, it's worth it to have this architecture, to use it, because we need to be available all the time. For Google and Salesforce, yeah, important elements are the domain-driven design, which basically means you put the business values and the business logic on top. So for Salesforce, it's the CRM data, the customer relationship data. That's the core of the system. Yeah, and it's super complex, and that's but the main elements. And those entities communicate with each other, and everything is built around that. Yeah? So I just want to make the point for depending on your use case, some things are so you are representing, yeah, you are presenting your results to somebody. And basically architecture always comes into place in these two steps. Yeah, data acquisition, so you need to get the data from somewhere. Yeah, for data analysis, this is usually some CSV or some Excel file or some database export you get from a customer, and they say, okay, I have the latest data and from the last quarter, and I want to know some KPIs. Yeah, but if you're building an app, you can't just download some CSV data. Yeah, so you need to get it from somewhere. And then also the reporting or deployment. So you need to provide your insights to somebody. Again, and if you are working in data analysis, it might be just you have your Jupyter Notebook results, or you have your spreadsheets with the KPIs, and you go to a meeting and present it or build some slides out of it. But in the app, the user logs in now and wants to get the information now. And so you need to automate everything, and you can't just say, okay, here's my spreadsheet or here's my data. So you need to present it, and also you need to present it faster. For example, if we take Netflix as an example, you know, I want to get a recommendation on the movies I want to watch tonight. So I want to log in Netflix and get the recommendation automatically, yeah, without any data scientist being in the background, downloading my CSV file of the movies I've watched in the past, then building a model and sending me the movies to watch back. Yeah, so we need to automate everything. And this is where basically data science needs to integrate with the software architecture of an application. Yeah? So these 2 points, getting data, then you're doing something with the data, but then providing the results back. And just a quick overview about the building blocks, yeah, what you might expect in a standard application, yeah, that is built today. So you usually have a backend and a database, yeah, for storing and retrieving the data. Yeah, this is usually a server, but today serverless is becoming more popular, which means that you don't have a server running all the time on some hardware, but you have some functions defined and they are invoked whenever they are triggered. So it's not running all the time, but you can trigger it. So for example, if you have just a user login, yeah, on a server, it would run all the time, and then you would send your information and it would log you in. On serverless, it wouldn't run, and you would then send a message and say, hey, I want to log in this user, and then it would run. Yeah, so it's cheaper, but also there are not that many functionalities for it right now, but it's super popular in the software engineering field. Yeah, and examples for backend languages, pretty much all software languages, Python, Ruby, JavaScript, PHP, Java, yeah, basically everything can be used with it. And for the database, so where you store your data, you basically have 2 choices, an SQL or a NoSQL database, like Mongo or Postgres. NoSQL is structured, yeah, basically have tables like in Excel, you have headers, and then you could put in the data. In NoSQL, it's the document storage, where not all entities have the same entries. So for example, in SQL, you would also always have a user with the first name, last name, email. In NoSQL, you could have users with the first name, last name, email, and address. Yeah, or just the first name and an email. So this is the difference. For data science, it's almost always better to have an SQL database, yeah, because it's just easier to work with.
Marius, many companies later on then decide that they have to migrate to SAP or the companies that, at least as far as I understand, have their special database structure, yeah, that allows more stuff. Does it make sense from the first beginning to start with these kinds of external solutions, or should you prepare for being able to migrate?
Yeah, I mean, SAP is for big enterprises. So you might use it at some point, and it's also for resource planning. So depending on your use case, so if you're a company that sells products, for example, with SAP, it makes sense to use it at some point. Yeah, smaller companies will almost always use smaller solutions, and also the lock-in effect on things like SAP or for CRM systems, Salesforce is the big one right now, is super high. Yeah, and so when you start using it, yeah, SAP or Salesforce, there is no going back. Yeah, but yeah, you might encounter it in big companies, and yeah, but usually you don't want to have it, or you have it if your main product is not really software. If you're building a software application, yeah, you shouldn't do it with Salesforce or SAP. But if you're selling some other goods, yeah, SAP is good. Salesforce is a CRM, so that's something else. Yeah.
Is that when large corporations, yeah, have own startup departments, basically? Yeah, do they sometimes force them to use the existing SAP or Salesforce solutions and thereby hinder their own innovation departments?
Yeah, there are some companies that, or there are a lot of companies. So I have also worked for a company that where I developed in SAP and Salesforce, so I know some things. So SAP and Salesforce are the big players in that market. They are pushing some innovative stuff, but yeah, the basis is still SAP, and they also have interfaces that you can integrate with. Yeah? So usually, I will talk about this also in a few minutes. How can data be sent and retrieved? So you usually can build an app that integrates with SAP, but then again, it's about, okay, do you really want to be part? Yeah. Do you really want to integrate with SAP, or do you or don't you want that? For example, at DealCode, what we are doing is we integrate with CRMs like Salesforce, Pipedrive, HubSpot. So because we use this as they have their data there, and it makes sense, yeah, to integrate with them. Yeah, and we retrieve the data, and then we do some analysis, some predictive modeling. But if you have, it basically depends on your use case. Yeah, if you need the data, so if you need sales data or data from the SAP system, it always makes sense to integrate. But if you build an application that does not need this data, it maybe needs other data, yeah, then you could do this as well, or you shouldn't integrate it because the data is not there.
Basically, you're saying that the fastest way to the market is usually doing something quick and rapid on your own. Yeah, so you build your own database, your own code, and using all kinds of standard solutions in the market is usually making you slower. Is that on average, right?
It really depends. There are some good. I think it depends on your use case. So if you are building on top of something that already exists, it makes sense to just look at their interfaces, because today a lot of software can integrate together. Yeah? You can send data from A to B, and then if you can integrate with some other software, because that's what we are doing at DealCode, we are integrating with other software, then we can contact the customers of that software. So we know, okay, you are using this CRM. Hey, you have a plugin, you just don't need to buy or need to have another tool. You can just connect it, with an API key or with some application. You just connect it, and then it's integrated. And it really depends on your use case. For example, if you would build something like Spotify, you wouldn't build it on top of SAP. Yeah, just to make this an example. Yeah. Okay, and yeah, this is the backend and the database. So you usually have your own, even if you are integrating with some other tools, you still have your own database for user data, for example. So what users are using your system, even if some of the data lies on some other database. And then you usually have a web front end, so everything that runs in the browser, or you have it on the desktop. But today everything is in the browser basically, and you have the choice between or the examples. Yeah, this is the top 3 right now: React, Angular, Vue are JavaScript frameworks, and basically all software as a service solutions today are built with these 3 frameworks on the front end. Yeah. And you also can build some mobile applications. Yeah. So the front end and the mobile application front end is just connected to the same backend and the same database. Yeah. So this is everything that runs on your phone. Yeah. Can either build it native for iOS or Android, which is 99% of the market share, or hybrid for both. Yeah. The native just means, okay, you build 2 apps basically, one for Android and one for iOS, but then all the apps look like native apps for that phone. Yeah, so all the elements on iOS look like iOS elements. Or you could go the hybrid way. The pro is that you just need to build it once, but the downside is that, for example, on iOS, you can't use all the features. Something like geofencing is not supported. Yeah, so we can't get the geo information on your phone. Yeah, so those are the trade-offs that you need to know when you're deciding on the tech stack. So a super basic building block would be something like this. You have a front end, for example, in React, a website. Then you have a back end run on Node.js, which is a JavaScript framework, and you have a SQL database. So this could be like an online shop or something like that. You have all the data in the database, you have the backend that does the calculations, and then you have the front end, which displays the shop to the users. So super basic. And I want to go into, there are a lot of software architectures, and in the enterprise, there are even more. So I just want to go into 2 basic types of architecture. This one is the monolith. Yeah, this is the old way of building software and the traditional way, which does not mean it is bad. As I said, it's always a challenge of trade-offs. Yeah, but monolith just means you have one code base, you have one unit. You know, if you look from outside, that's just one thing. You have the user interface, you have the front end, then you have the business logic and the data interface, which are on the back end, and then you have a database. Yeah? And you have no modularity, all the logic, everything works in here. This is really easy to develop and simple to deploy. So easy to develop, yeah, you just work on one code base. And simple to deploy. So deploying is just bringing it up to a server. So you have one code base, you just put it on the server, run it, and it's running. And debugging and testing is also easy because you have one code base. Yeah, if it's, you can just test everything there. You don't have any communication between services. There are no services that could go down. Everything is on one hardware. Either the monolith is down or up. Yeah, you can't have something that like the user registration is down because one microservice is down. Yeah, that would happen here. Then the whole application would be down. Yeah. The cons are scalability, and this is a big one. Yeah, as I said, a lot of companies have big problems working with this monolith architecture that they decided or not decided and just started back in the day, and now they need to scale it up because, for example, let's say we have a software that has some recommendation algorithm and some machine learning in it, where we need a lot of GPU power and have long-running tasks. So everything is running on one hardware here. So just because one part of the software just needs a lot more resources, we have to buy bigger servers with more computation power, which might not be used 99% of the time. So most of the time, a smaller server would be enough because you just have some users logging in, looking at data, but maybe once a month we calculate something or have a long-running task that uses a lot of power. Yeah, then we would need to build something for this use case, or everything would be on this use case. And also making changes in a monolith. You could break everything. So this is you will encounter this at some point in your career, working with it and breaking it, and then you will know that you are working with a monolith, because if you make a change, it could break everything. So for example, you make a small change on the recommendation algorithm and it breaks, and all the website is down. The users can't log in, nothing is working anymore because maybe some parameter in the algorithm is not correct. While if we build it more modular, then the algorithm wouldn't work, but users could still use it and could still log in, look at their data and see everything, and everything else would work. And so let's come to the second type of architecture I want to introduce, which is the microservice architecture. This had a big hype in the last years in the software engineering field. And a lot of people now say, okay, we should build everything with microservice, but they are just jumping on the wagon because it's so popular. And as I said, Netflix is using it, big companies are using it. Yeah, they are using this because they are big companies. They have the power to develop it. Yeah, and they have the money to develop it. Yeah. But the idea of microservice architecture is that you break down a single application into small services. All the services are running on their own and communicating with each other. And each service covers their own scope. For example, Spotify, we might have a user service, just responsible for logging in users or registering users. Yeah. We could have a streaming service. The streaming service is responsible for getting a lot of data from the database and sending it to the user. And then we might have a recommendation service, which is just responsible for getting all the movies that you've watched in the past and generating recommendations for or not movies, we are Spotify, not Netflix, but listening to or looking at your song history and then creating the mixtapes you have in Spotify, for example. And as you see, each of these microservices has their own database. So all the users are in one database, all the recommendations are in one database, all the data for the streaming service is in one database. And you can't access any other database. So the recommendation service cannot look at the user data. So it's very modular, which is always, or is good, but also in some cases harder to do. And the pros are obviously, independent components. You can have different teams working on each service. It's easier to understand if you say, hey, I'm working on the recommendation team, and you know your code base, you just need to look at this part, and the other things are not relevant for you. Scalability. So example, Spotify, the user service might be a super small server. You just have some request authentication of users. But the streaming service, there is a lot of data that goes through that service. Getting all the songs from the database, sending it to the user. So there is a lot of traffic on this service. So this might be a lot of servers. And the recommendation service, this might be a service that has a high CPU or GPU amount. So the calculations from the machine learning models or the generation of the models is faster. One
question.
Yeah.
Do you also have any recommendation regarding the security of such an architecture? So for example, my feeling is that it's more secure to have it modular. So if, for example, there's a bug in one of these microservices, could be misused by hackers. So it couldn't spread very fast, right?
For example, if you see user data, this database might be a lot more secure than just having the recommendation. Because if I hack into this database and I see, hey, user with the ID of 5,000 has recommendation of ID whatever, you can't really do much with it. Yeah, as an example, if you break into the database on the Monolith, you basically know everything. Yeah, you see all the users, all the data, everything that's linked to the user. Yeah. And here you just break this database. Yeah. And one thing also, yeah,
another question. But you really need a good understanding of your use cases upfront, right? Because you cannot just switch the microservices and databases with each other.
Yeah. Yeah, you need to know it upfront, because this is also how many monoliths are built. They don't know it, they start, and then they just add. Yeah, and at some point they say, oh, it's so big, we probably should change it. And then they try or not try to change it. Yeah, yeah, you have to think about the use cases very well and the abstraction, but you also could start, for example, if you have just an idea, yeah, a user microservice is always a good idea to have something like that. So you could just build on top of that. And another pro, which is very, very good, is you're flexible in technology. So the user database could be, or the user service, yeah, the microservice could be in JavaScript written on the back end, just using the authentication modules, while the recommendation service is a Django or Flask server, yeah, because you are probably using Python for the machine learning part, while the streaming service is some proprietary streaming library that you bought from somewhere, yeah, because you really need the data throughput there. But there are also some downsides. So extra complexity. That's why most smaller companies or startups don't use it really, because you at the end you have the same product, right? It's, yeah, availability might change, but it's the same for a non-tech person who just looks at it. Yeah, and you don't see the complexity. And then a lot of yeah, you can't really sell it. Yeah, you can say, okay, in 3 years we will be happy that we chose this approach. Or you have some, for example, in the startup, some founders who are tech savvy, who know their stuff. Yeah, that they should start with it. But yeah, the extra complexity is it most likely not worth it at the beginning stage. Yeah? And because you really need to abstract everything, you have more databases, which is more expensive. Yeah? You need to structure everything, which takes longer. Yeah? If you do, you really have to think about, okay, I need to build this functionality. Okay, where do I build it? Yeah? And you also have a distributed system. Yeah, so everything needs to communicate. Yeah, here you have everything on the same hardware, no need. But here everything might be distributed all over the globe. Yeah, at today's time, and you need to make sure it can communicate. And what happens if, for example, one service is not reachable? Yeah. You have a lot more cases to cover there. Also testing, yeah. Testing also could be a pro because you can test each microservice at once. But if you want to test everything, you also need to test the microservice, but also the communication between the microservices. Yeah? And it's also hard if you are a tester in one microservice team. Yeah, you probably just know what's going on there, and you don't know a lot about the communication. And so it's also hard for testing, yeah? And of course cost. As I said, you need more servers, you need more databases, you need more development power, and you just need more time at the start. But yeah, as I said, trade-offs, for example, Netflix, Spotify are using it because they need to be available all the time, and it really fits into their paradigm. And what a lot of companies do is they start with something like this, and at some point it generates enough revenue that they can switch over. And then you always have this transition period in the company.
Mario, from the experiences that you saw in the market, do you think that CTO of a startup is most important for really designing a long-term stable solution that is flexible and scalable? Or is it the presence of a venture capital fund that have experience in these things and that basically exercises its own wish list?
Yeah, I mean, the worst part is if you have no tech founder in the startup and trying to build a tech solution, because then you need somebody in the VC, yeah, who is doing that for you. But in my opinion, you need, it's not the important role. I think CEO is still more important for the company in general. But for this part, CTO or having somebody tech savvy in a startup is super important to just make these decisions. But because all these decisions are very costly to revert at some point. Yeah, and if you think about as startups and venture capitalists, you can't, or you're always telling your roadmap to venture capital, and you can't just say, if they ask, okay, what are your plans for 23? And you say then, okay, yeah, our plans is we develop on it with 10 engineers the whole year, and at the end we have microservices implemented. And then they, okay, but what can we do with it? Yeah, we are better off in the future. Then always the question is, okay, why haven't you done it from the start? And you always have these questions. Yeah. So it really depends. With some products, it's also good to build just a monolith and add some microservices on the top. So you have a core product and your core application, and you have some microservices that is providing some data, yeah, which might be a trade-off in the middle. Yeah. Okay, and I also wanted to talk about what you will most likely encounter when you are on the data team. You will most likely, as we already talked about, you will need to get data from somewhere, and you need to provide your results somewhere. And you will most likely be building a microservice. Yeah. At today's time, if it's a microservice like this, or you just build a microservice that connects with the monolith, yeah, but it will most likely be a microservice. And you will need to provide your insights via API. Yeah. And this can be done with any backend technology. I showed, for example, a simple Flask server can do this. And the communication between the app and the microservice would then be, okay, the app asks for a recommendation, for example, for Spotify, hey, I want to create a mixtape for this user. The microservice does the calculation and then would respond with, here, this is the mixtape, and the application could show. And I just want to quickly talk about this communication channel. Yeah? An API enables applications to communicate with each other. There are some different APIs. So you have SOAP, which is probably the oldest in the list. Then we have the REST API and GraphQL. But if we take a look at today's standard, you pretty much have HTTP plus REST is the standard right now. And the HTTP protocol basically works with a request response cycle. So you send a request, you get a response, and each request consists of a verb, something like get, post, put, delete. So get if you want to get data, post if you want to send some data, put if you want to send or update, delete if you want to delete, and some destination, some URL or route. And then you get back a header, a body, and a status code. You probably have seen the status code on some pages when you get a 404 back, which is not found. 200 is the best. Yeah, it's okay. Everything was fine. So how would this look in your application? Yeah, you would send, for example, a recommendation to a Spotify / recommendation user ID. The app would ask for this. Yeah, and then the response would be some header, some meta information. Yeah, for example, a recommendation of 0.37, whatever this is, and a 200 status code. Yeah. So you would get the information about the user ID, you would generate a recommendation for this user, and you would send it back. Yeah. So this is basically what data analysts do with the Jupyter notebooks. Yeah, you get a request for something to build. Yeah, you build it and then you show it in your notebook, but now you're doing it on a server with a request response paradigm. So this is was my short overview about system architecture, and we have some application, some practical application on it. I prepared 2 tasks. We have, first of all, you need to have Python 3 installed. Yeah. Then I uploaded some code on this URL. You will find it on my GitHub. You can either download it as a zip file or just clone it if you have Git. And then there is a README. You just follow this, and you can get the boilerplate up and running. Yeah.
Can you post the GitHub link in the chat?
Yeah, I can copy it, I think. Yeah, I sent it to everybody. Where is the Zoom chat? In the chat. Yeah.
Do you prefer us to work in teams, or you just want to show in the beginning?
No, I don't show anything. You can either work in teams or you can work alone, whatever you prefer. Then we have some time to set it up now. Yeah. So we have when you run it in your browser and you see the I'm running message, you are set up, and then we can go over to the tasks basically. So you can download it. Yeah, go to code, either download as zip or clone this if you know how Git is working. And then there are 3 simple steps to get it running.
So my suggestion is to create 2 big rooms, and then someone in each room can screen share and yeah.
First task is you have in the training data set, you have information about the passenger ID, yeah, and the survival status of the passenger. And in the boilerplate, you already have the route / whatever, so you can pass in parameters. I want you to add another route, which is survived, and then the ID that takes this ID of the passenger as an input parameter and responds with either yes or no, depending on the survivorship status of the passenger. You can test it in your browser. You just go to this route, put in some ID, and compare it to the data set. So this is just the training data sets. And if somebody has done it and wants to present their code, we can do this.
I start recording again, and let's share my screen. So what I try to do is to just import Panda and then read the database that you have.
Mm-hmm.
And then, so I created the root here that survived an ID. And then I create a function that returned the integer of that ID. And then I search through the database that the passenger ID should be this ID, and then I get the survival status. So basically.
Yeah, and I think this is the problem, because what does the comparison return? It returns 1 or 0, right?
Yeah, it should be a string again, right?
Return a string, yeah.
Okay. Okay. Survived.
Yeah.
Okay, yeah.
And try 1. 1 did not survive, and 2 did survive.
1, yeah, didn't survive. Yeah.
Okay. Yep.
Obviously, I can make it more beautiful. I just very dirty solution. Is there anyone with a better solution? Can share the screen?
Anybody wants to share?
I don't want to share. Just did I understand right that the customer ID is part of the internet of the HTTP address?
We can.
Yeah. You could also add it to the body. So
Yeah.
how you usually would do it. Or you would add some other authorization in front of it. Yeah. But maybe
Yeah, it's a nice idea just to put it in the HTTP address, yeah, because then you don't need any HTTP page, yeah, with a command entry enter.
Yeah, maybe I can share my solution if you want.
Sure.
Yeah. So this is my solution. Yeah. So basically what you do, yeah, you define the route, get the input parameter. I'm reading it here, which is very bad. Yeah, this should be, yeah, because you would read it now every time you would load it when you get a request. So you can also do it on the server, on startup. Yeah, then you just look for the passenger ID located and return no if survived, or else otherwise. So this is very basic. This was the easy task. So now we are gonna take a look at the second part, which is the training data. Yeah? So we have still the same data set, but now we don't have the survival status. And now we are building a machine learning microservice. Any machine learning model can build whatever you like based on the training data set to predict the survivalship status. So I call this route predict with the ID, and I want to know if the passenger with that ID will survive or not based on your model. Yeah, it could be a good model, bad model, doesn't really matter for this use case. So the test then test it on the test data set. And one thing you need to do, you need to build the model first, because building the model once you request this will take a long time. So usually you build your model, you can add another Python file where you just build your model, save it to the file, and save it to a disk. And then once you call this route, you just load up the model, run it through, yeah. And yeah, you can test it in the browser as well with the passenger ID, and in the test set, the passenger IDs start at 892. So you can test with those IDs.
And this is an open-ended task, right?
Yeah, this is an open-ended task. So what you can start with a very simple model right now. Yeah, just maybe returning some random result. Yeah, and then you can just open-ended try to build a better model. Yeah, track the accuracy of your model, and then serve it. So the idea is not to build the best model here. That's for later, but just how is the process in building a model and providing this information to an application, because the application will do the same thing. The application will send the request. Yeah, if you have a Titanic application, you have a front end, you can look for the user ID, and you have a send button, will exactly do this and get back yes or no and display it on the browser. But of course, the model with the highest accuracy will win.
So I just share my screen for a second to ask your opinion. So what I will do, I create a route first. So the route of predict ID, and then I return a predictor function that could be a machine learning, right?
Yeah.
So and then I create a function on the top. So for now, I just return 1 always. Or I think for better accuracy, I can return always 0. And yeah, and then I guess then you could build on top of that anyway any time you want as a homework. That's a great homework, I guess. Yeah. For the students. Yeah, start from whatever model you could imagine, and then you have a website then at the end that can predict something for you. Yeah. It's very cool. But
yeah, maybe I can just go through a quick solution, because we don't have that much time anymore. Let's see. Yeah. So because so here my solution, I used again same error, I'm loading it here, but what I pretty much did, so I generated a model on the side in another function that runs just once. So it does not run every time we call the route. And then I just load it from the disk. Yeah. Then I get the index of the passenger with the ID. And then I do some cleanup for my model that is required. And I predict everything. And yeah, as it is a binary classification, I then pass it to binary and pretty much, just return no if the result is 0, else I return yes. And this is just, as I said, don't concentrate on the model too much. You can do it in your homework assignment, but this is just the workflow. You on the request, you pretty much don't want to do any long-running tasks. It should be fast. You don't want to calculate any new models. Everything should be done on the back. The back prior to that. You just want to get the ID, get the prediction for that, and go from there. So that's my solution. I hope, Sasan, you don't kill me for some of the data cleanup.
Yeah, that's great. But I think you use a model that is already available in Kaggle, right? So it is like an ML model that you load and the file is downloaded some, uploaded some. Yeah.
Yeah, let's see.
Yeah, this would be my question. Where do you know that this function exists?
This is my model file. Yeah.
Okay, so you have
some deep learning.
Okay.
So yeah, basically I did this and then I saved it. Yeah. Okay. Just to file, so I have it here, and I can load it.
Okay. Okay. See.
Okay. Very cool.
Yeah. Very nice.
Marius, can you give us a quick intro into what your model is actually? What is the logic behind your model?
I built it for Kaggle some years ago. I don't know anything anymore.
Yeah, okay. Don't mind.
Yeah, maybe I can find it and then I can send it later. Yeah.
But so, for example, what's the logic of classifying on 0.5? So didn't you optimize the best cutoff somehow in the model?
No, obviously not. I just when preparing the slides, I just wanted to have one model because I don't want to build one from scratch, and I had this old code lying around, so I just took it. And
okay.
I'm sure that you can run a contest on which model is best, and this will beat mine.
Yeah. But a typical user would go to Kaggle and look for models and then incorporate this.
Yeah, you could do something like that. Yeah.
And because standard databases, right? So
yeah,
for example, Titanic is very, very famous.
yeah, I think it's one of the most famous data sets that they have. Okay, so move on. I just have a few more slides. Some tools I can recommend when you want to start working in the cloud and working with some cloud functions. For example, on AWS, there are Jupyter notebooks in the cloud that you can rent. So if you have very long-running tasks or need some GPU-intensive work, you can do it there. So if you want to really optimize your models for this homework, go on there and run it. Don't forget to shut down because you pay for the time you're renting it. Then AWS also has Lambda, which is a serverless. So you can, without building a server, you can, like we did with Flask, you can run functions. So you can just define a function that does everything there, and then you can call it, and it doesn't run the whole time. Just pay when it's called. On Microsoft and Google also have some cool machine learning tools that are worth looking into. Google Colab is very cool because you get a lot of free time there, or some free computation power. You can spin up your notebooks, run everything there, build the models, test everything. Heroku is one of my favorites because it's super simple. You can deploy your code. So like this Flask server, you could deploy it within minutes, from a GitHub, for example, or from your local drive to Heroku, and then you wouldn't need to put in the 127.0.0.1, but you would get a URL from Heroku, and you could do it in the cloud. So you can just deploy everything to another server, and it's running there. They also have some free tiers, and another great tool is Postman, which is an API testing tool. So basically, what you did in the browser is always a GET request. When you type in the bar on top. And in Postman, basically, what Postman does is you also can send post requests, delete requests, you put in your URL, and you can save all those requests. So you can really put together, when you are building a microservice, you can really put together all the endpoints that you need and then test everything.
Just one question. So we have in the course we have some presentations on AWS and Google Cloud, so students already know about them a bit. But the Heroku is like very new for me. So could you just compare a bit what they offer that, for example, Google and Amazon don't?
Basically, Google and Amazon do the same as Heroku, but Heroku is very easier to operate. For example, in AWS, you have the big console, you have 500 different services. And Heroku is very simple. You just say, for example, if you want to deploy this Flask application, you can put it on GitHub, and then I can go ahead and say, okay, whenever I push something to GitHub, I want to deploy it to Heroku. I get a URL. I can rent a database with a few clicks. I get the login details for the database. I can store the data there. So that's super simple to use. So I can recommend Heroku for everybody who's starting out. If you want to build your application, start with Heroku, simple to operate. And then recommended readings towards data science is a super cool blog. They have a lot of everything regarding data science. And if you look for the software architecture tag, you will see a lot of good articles about different architectures, about some trends like big data architectures who are very different from everything that we now talked about, because the data throughput is so big. So you can just subscribe there and get the news and read it.
Marius, one question, I hope it's not too stupid, but when you talk about app, you mean a web application, basically, that you use the web browser in order to start and receive something. Okay.
Yeah, either a web application, could also be a mobile application, a desktop application as well. So everything pretty similar. I mean, today most of everything is moving to the web.
Yeah. Yeah, but you call this data science architecture tools. Isn't that a bit broader than what you have been talking about? Is web app really the central piece?
Yeah, I mean, those are the pieces to put together the architecture, right? I just talked about a few now, but because on AWS there were so many services, for example, yeah, usually you have a problem, and then you say, okay, what do we need here, and what is provided in the cloud? Because you always have to make the decision: do we buy something? Do we rent something? And renting is usually better, at least if you're starting out. If you don't have a big data center, you know, renting everything, and then you need to think, okay, what parts of the system can we use? And for this, AWS, for example, has a lot of services that you can use. For example, they have also a service where you can automatically tune machine learning models. They have another services, and then you can integrate it together with your application. You can say, okay, we are using this service for this job, this service for that job. For example, they also have something similar to Heroku, which makes deployment easier. So the software engineers don't need to do manual deployments, yeah, copying the code on the server and running it there, but they have some pipeline where they just press a few buttons and everything is automated. These are the tools to build architecture together. And maybe there is also, on AWS, you have an overview about the services, and there is also an overview about the big services. Yeah, and you can take a look at that. Okay, I think we are done. We have 3 minutes for a Q&A. So if you have any questions, if you want to, yeah, get any feedback on some ideas of yours, now is the time.
Could you elaborate a little bit on the NoSQL databases? Why would they be used, and what's the benefit?
Yeah, the benefit is that you don't have you don't need a clear structure up front, and you don't have to run migrations. So when you have an SQL database, you always have a structure, yeah. And when you need to add some fields, yeah, you want to add some fields, you need to migrate the database, to change the table. And this is usually a lot of migrations after each other. And in NoSQL, you just add it in the code. So it's a little bit faster, because then all new records just get these fields. The old records don't have them. In the SQL database, the old records will still have them. It will be, yeah, and then you have to decide on the strategy how to fill these fields. Yeah. Sometimes you just say, okay, we have a new field, all old customers just get a null value, but sometimes you also want to get the field again from them, or you need to clean it up. So for example, for data cleanup, you would need to take the median or the average, yeah, of the field of everything else, yeah, of the new customers. So one thing where NoSQL is very, very cool is for small apps, yeah, where you really where things are changing quite fast and you don't know the structure up front. Yeah. So if you build something where you already know all the entities and all the fields you will have, or they are very standard, you can use an SQL database. NoSQL is if you want to start out and build on top of that.
I would like to ask a more personal question. People like you can choose to be employed by a corporation. They can basically be self-employed and work on an hourly basis and then get the job from the internet, or they can found a company and basically try to build up something. How many people actually are in a typical employment relationship, yeah, as normal employees, and what is your choice, and what are the pros and cons there?
Yeah, so as a software architect, you are usually working in bigger companies, at least if you are only doing the architecture role. and because then you also have the differentiation between software architect, enterprise architect, the system architect. So because in big corporations, there is more to worry about. And you have different departments, how are they working together? As I'm a software architect or SaaS architect in a startup, I'm doing a lot of other stuff. You know, I'm architecting the system, but I'm also product management, kind of developing on my own a little bit. There are some people who are freelancing or consulting software architects, so who get usually either hired to check the architecture that they have planned. So the company plans an architecture and you get an external view on it and do one project running a few months, checking everything before implementing it. Yeah. Or they are really hired for long term, and so there is a shortage of good software architects, because there aren't really many and the demand is high. So that's the choice for some people who want to really be freelancers or be consultants, and want to pick their jobs.
Yeah. So the typical strategy for a startup is to hire some technical people and get the rest of the work done by freelancers, which are then selected by these technical employees.
No, I wouldn't say that. I think in a startup, it's good to have some tech-savvy people early on. Yeah. So if you're building a tech product, and then I'm a big fan of also building an internal dev team, which is at the core of the team, and then maybe adding some external resources if you can't find something. I mean, the job market in Germany is for developers or data scientists is pretty good. Yeah, so they are hard to find, and there are a lot of companies now outsourcing to Eastern Europe, most likely, to just get more people on. Because that's just the problem right now in the job market. There are not enough developers, data scientists, UX designers, or whatever.
One question.
Yeah.
Which resources can you recommend for front-end development or to get started in general?
Yeah, for front-end development, it depends on what you're interested in. So when you will probably either learn or choose a JavaScript framework, so React, Angular, or Vue. I would probably just look at the websites and just see what's promising. And for you, I know the job market for React is very good at the moment, but Angular is also good. And React had a hype in the last few years. And I'm really a fan of either the documentation on the React side, which is quite okay, but there are also very good courses on Udemy. I've seen them for React development where you see the ins and outs, but I think the most important part if you want to really learn development is just doing stuff. And it's not, you won't have one course that teaches you everything. You have to start with the problem and then just start building. So yeah, if you have an app idea, just pick a framework that you really like. Yeah, almost everything can build with any technology today. And then start building. And once you run into some problems, Google it, find a solution, build it, and then go from there.
Yeah. Okay, thank you. Because I was thinking, I know Python, I know SQL, so basically the backend and database stuff is fine, but on the front end, I'm completely lost until now. And I think Flask is nice to share information, but it really looks ugly. So or at least what I've seen so far. So if you want to deploy anything where you work with customers, it would be nice to have something that looks a bit more engaging, I'd say.
Yeah, sure. Yeah, I mean, most people don't use Python for front-end stuff. You could do it, but there are better choices out there, in my opinion, for the most apps at least.
Actually, you need front-end development if you are like a full stack developer, yes. So if you are concentrated only on back end, then you probably don't need much knowledge on that, probably, yeah. But of course, being a full stack developer is much more better, yeah. So
yeah, it also depends, yeah. If you are very good at backend or frontend, it's also very good. Yeah, it's better to be specialized and very good than to be like a full stack, but don't really know the in and outs of every part. So I would really concentrate on one. But if you, for example, yeah, if you want to build an app yourself, yeah, you need some front. So yeah, should look into that.
Okay, more questions? If not, yeah, thank you very much, Marius,
Yeah,
again. That
thank
was
you.
a great discussion. I think students also loved it a lot, and now they can also train more themselves with Flask. And yeah, feel free to share your solutions in the Piazza forum that we have. We can compare and see who's predicting better at the end. And yeah, and if you are searching for some, yeah, I think you wrote it here already.
Yeah, so you can connect on LinkedIn if you have further questions, or if you have ideas for apps and just want to get a review or some insights, just to somebody to ping your ideas off. Yeah, just ask me or shoot me an email on LinkedIn or shoot me an email. And as I said in the beginning, we are always looking for talent at DealCode, data scientists, developers. Yeah, you can check it out what we do, and if it's promising, just send me a mail or use the contact form on the website.
Okay, great. Thank you again, and for all of the others, have a great days ahead, and nice weekend in front of you. Yeah, bye bye.
Okay. Yeah,
Thank
thanks,
you,
Marius.
bye.
Bye bye.
thank you, bye.